Today we're going to be talking about special functions. And more specifically, we're going to be talking about piecewise functions. These functions are super important and we're going to be covering them throughout the year. So a piecewise function is a function who is composed of multiple functions. So we have basically three equations that'll make up our one function, but they have domain restrictions. So they tell me what that means is we're going to graph this top function restricted to our x values for just those x values that are less than -4. And we're going to graph this function for the x values between -4 and 3. And then we're going to graph our bottom function between the values of x that are greater than 3. Evaluating a piecewise function. I think that this is important. So evaluate the piecewise function for -1. So h of -1. So we need to pick one of these two functions. We need to decide, is -1 less than or equal to 2, or is -1 greater than or equal or greater than 2? Well, -1 is less than or equal to 2. It's the bottom, or it's the top function. So you plug it only into the top function to evaluate. So when I plug that in, we get -2 plus 1, which is -1. Now to find h of 2. To find h of 2, you plug in 2 wherever you see an x. Now we need to decide, and I kind of gave it away a little bit, h of 2, well, when x equals 2, again, we use our top function. So we plug in 2 into our top function, and we get 5. Now, for x equals 4, we need to decide, is 4 less than or equal to 2 or greater than 2? Well, 4 is greater than 2. So to find h of 4, we're going to use our bottom function. So I have 16 minus 4, that's going to be 12. So that's evaluating our piecewise function. Now graphing a piecewise function and identifying domain and range. So graphing the piecewise function. You graph the top function, y equals 1/4 x plus 3, for just the numbers that are less than 0. And notice how I have a little reminder here. The graphs are never dashed or shaded. When it's less than, when x is less than 0, that means we're going to have an open hole where that point would be. So graphing this line, we have our y-intercept is 3. That's going to be an open hole since x is not equal to 0. And I'm going to go down 1, because it's a positive slope, so I have to go down and left and down and left. We go down 1 over 4. Let's get at least a few more points on our graph. So that's what that piece of our function, or a piece of our piecewise function, would look like when we graph it. Now, the bottom function, or -2x minus 3, for x is greater than or equal to 0. So I go to -3 because that's my y-intercept, and then I plot out my slope. Notice how I have a filled-in hole at -3, and I go down to right 1 because I went negative positive, plotting out our slope. Okay, now figuring out domain. Okay, when you're figuring out domain, you have to figure out, okay, are these two functions, do they have any domain restrictions amongst the points that we've plotted? Since they're both lines, we have no domain restriction. And since The only part that we might have a domain restriction is at our, what I call the breaking point. But since for the top function I don't include 0, but for the bottom function I do include 0, our domain is all real numbers. Now the range is a little bit more complicated. Okay? This bottom function, we start at -3 and we go down and we keep going down forever. So that's going to cover all of our values that are less than -3 for y. Now I need to see what the blue function does. Well, the blue function basically starts all the way down here, -infinity, and goes up, goes up, goes up, goes up, all the way to +3, and doesn't continue going up anymore. So the highest point that we have for y's is +3. But we've covered everything less than it. So y such that y is less than or equal to 3. Because this function has its stopping point at 3 but covers everything less than 3. Now if there's 3 functions, graph your top function. Okay, that looks like the line y equals -2. We know that that's a straight horizontal line for x is less than -3. So I go to -3, I go down to -2, I have an open hole because we're not equal to at -3, and it's a straight horizontal line there. Our middle function has a slope of 2/3, but nothing's added, so we have a y-intercept of 0. What you can also do to figure out your starting points is you could plug in -3 into our function. When I plug in -3, we get an answer of -2. So that's where our graph is going to start. Now it's kind of convenient that our top function, the green one, and the middle function kind of start and end at the same point. So the hole gets filled in. And then I go up 2/3, but I have to stop at +1. So we stop about right there. Now the bottom function. So y equals -4 minus 5x. So what you can do, again, what we could do is we could find f of 1 and put an open hole there, but realize that that gives us at least a y coordinate where we can put our graph. So I have 4 minus 5, that's a -1. So -1, I have an open hole. I have a negative sloping line, so I go down 5, right 1, and we have a negative sloping line. Now I didn't write it in, but we can't forget to find our domain. And our range. Okay, so to find the domain, have I covered basically all of my x's? Do I have any x's where I don't have a filled in hole? Well, we start at -3 and we go all less than, so that covers everything less than -3. From -3 to 1, yeah, I have all my x's covered there. At 1, yeah, we jump, but that's still, we have a filled in hole up there at the point, what would that point be? That would be the point 1 and 2/3. So, and then the bottom function covers all of them. It's not going to cover them super fast, but it's eventually going to cover all of our x's, so we're all real numbers. Your range. Think about what y values aren't covered. The bottom function or the red function covers everything less than -1. As they move up, do I cover what's my highest y point that we've graphed? The highest y point that we've graphed is this 1 and 2/3 point. So where we go from there is we say, okay, y is less than or equal to, because we're including that, 2/3. Now writing the equation of the piecewise function. And I'm going to be looking for the notation. You have to have an f of x equals or a y equals or something. You probably want to pick f of x because they tell you in your graph you have f of x. Now figure out your breaking point. My breaking point happens at positive 2. So I'm going to have a function that's greater than 2 and a function that's less than 2. Now, which one of those do we have a filled-in hole at? We have a filled-in hole for our numbers greater than. So numbers greater than, we're equal to. Now, what's the equation of that? Well, that's a straight horizontal line. So that's y equals positive 1. And unless otherwise stated, let's assume our graphs go by ones. Now the bottom function. Okay, now our bottom function, we have to look at. Okay, can we tell from our graph what the y-intercept is? We can tell the y-intercept is equal to -4. Now can I count out my slope? Our slope ends up being 1. So the equation of that would be y equals x minus 4. Y equals x minus 4. Now what if I had 3 functions? Okay, again, figure out your breaking point. I break at -2, so I'm going to have numbers less than -2, from -2 to +2, and I have my equal to signs because I have filled in holes, and then we have our numbers greater than 2. Now, I personally think the easiest one to look at right away is the middle function. The middle function, that slope is equal to, I go down 1, right 2. So my rise over my run is -1/2. We can tell from the graph what our b is. Our b is equal to 3. So our middle function is -1/2 x plus 3. Now you pick one of the other two. I'm going to pick the one to the left. Let's figure out what our slope is, and hopefully we're going to be able to count out what our y-intercept is. Okay, so our slope. Pick 2 points that we know are on the graph. We know this point right here is on our graph. We know this point right here is on our graph. I count up 2 and right 1, so I go up and up. So it's a +2. Now, if this line were to continue on, keep counting out where your points would be to help you find your y-intercept. As I keep counting out my points, I find my y-intercept is up here at +3. So if this were a complete line, our y-intercept would be 3. So that helps me write the equation for numbers less than -2. Now our last function. Again, let's figure out what our slope is. Let's figure out what our b is. Our slope. Pick 2 points. I'm going to pick this point right here and that point right there. So I go down 2, right 1. Down and right gets me a negative slope. Now count it out from our endpoint. If this line were to be extended, I go up 2, right 1. Up 2, right 1. My grid stops at 10, so it's up 1 more, so it's +11. So our b is that. So that's what the equation of our piecewise function would look like. Okay, there are your lesson questions for the day. It's a multiple choice question. You need to figure out which piecewise function is graphed at the right. And please make sure that is submitted on time.